Hi, in this video I'm going to show you how to calculate the standard deviation. In order to do that, we're going to start with the variance first, okay? Remember when we did standard deviation for a set of data, a numerical variable? Well, it's going to be sort of like that, so some of this will be familiar to you. Okay, so we have our same table. Let me put it down just for a second. We have the same table where we just found the expected value. And now we want to find the standard deviation. In fact, I'm going to need to keep that there so we can see it. Okay, so the first thing we do, remember deviation is how far away from the mean something is. So we're going to take each value and calculate that deviation and see how far away it is. Okay, so the thing we're calculating first is called the variance, and it's abbreviated VAR, the variance of x. Okay, so first we take our first number, 145, minus our mean, which is what we got right here, 154.4. And then do you remember the next thing we did when we calculated the standard deviation? We subtracted the mean from every single number, and then we squared every single number. So we're going to square that deviation, and that makes it positive so that the deviations don't cancel out from each other, with some being negative, some being positive. And then because this is an average, it's a weighted average, just like our expected value is, we're going to multiply by that probability of that outcome, whatever it is. So in this case, it's 0.15. And that's one term. So we're going to do this for every column, or it could be row if the table was set up differently. Our next value is 150 cups of coffee. So we calculate its deviation, 154.4 squared, times the chance that will happen, so plus 0.22. Okay, now I'm not going to be able to get this all in one row, so I'm going to go ahead and go down here, and you have the table and I have the table up above, so it's okay if we can't see it. But the next column over is the 155 minus 154.4 squared times its probability, which is 0.37. The next one is 160 minus 154.4. That's the deviation. Then we square it, multiply by its probability. And we have one more. 170 minus 154.4 squared times 0.07. Okay, so let's calculate this. And in order to do this, I don't want to have any round off error by rounding these individual terms. So I want to keep it all in my calculator. So I'll show you how I do it. There's other ways to do it, but I'm going to do my first term. So parenthesis 145 minus 154.4 close parenthesis squared times 0.15 and enter. Now that's not too bad, it's only 3 decimal places, but it could be worse. So I'm just going to keep that in there and then add the next term. And I'm going to do that all the way until I get all 5 terms. This calculator won't let me enter this long of a string in, but some of them might. So you could do it that way too. 150 minus 154.4. If you'd rather just try it on your own, feel free to pause the video or skip ahead, see if you get the right answer, times 0.22, enter. Plus, I'm on the third one now, 155 minus 154.4 squared times 0.37, enter, plus 160, sorry you can't see it all that on the calculator, 160, oops, I forgot my parentheses, 160 minus 154.4 squared times 0.19 plus the last one, parentheses, 170 minus 154.4 squared times its probability 0.07. Okay, so 40.64 is what I got. And remember how we took our differences, our deviations, and we squared them? So we're not in cups of coffee right now. We're actually in cups of coffee squared. And that was the same thing that happened to us when we did the standard deviation. We were in square units. And the variance is the one that has the square units. So in order to undo that square and get the standard deviation, we need to take the square root. So standard deviation is labeled with sigma, or in this context we also use SD of x. It's function notation. It's the standard deviation of x, and that is the square root of 40.64. And then we'll get back to cups. So square root 40.64 is 6.37 cups of coffee. Okay, so you might be wondering, what does this all mean? And I hope you are wondering that. What does a standard deviation mean? So we've calculated for this table, this random variable, which is discrete, only these certain values are occurring. We found that on average, this coffee shop will sell this many cups of coffee. So let's do that part first. So on average, the coffee shop will sell 154.4 cups of coffee per day or per morning. Then standard deviation is a measure of spread. It's saying, well, are all the mornings really tightly packed together around this 154.4, or are they really spread out? And so that's what the deviation is. Standard deviation is the average deviation. So you can think of this as the average deviation from the mean. So also on average, they'll sell about 6 cups, a little over 6 cups, away from the mean. So you could think of 6 above or 6 below. So we could say the average deviation from the mean or average distance from the mean is 6.37 cups. Now, if we had a different coffee shop and their average deviation was 20 cups, that would be a lot bigger, that'd be a lot more spread, right? And if we had a coffee shop with a deviation of 2 cups, that would be a lot less spread. So it's a comparison to where we can see, we can kind of measure the spread of the random variable. Okay, so that is talking about how to calculate first the variance, and then the standard deviation, and then the interpretation. Now let's look, before I stop this video, let's just go over all these symbols, because just like the previous formulas, you don't have to use them. They're basically summarizing the procedure that we just did. So look what we did. We took the value minus the mean, right here, each value minus the mean, and then we squared it. So right here is the deviation. Then we squared it, and then we multiplied it by its probability. And then the capital sigma means add those all together. That's a sum. Add those all together, and that's our variance. And then in order to get the standard deviation, we take the square root of the variance. Okay, I hope that helps, and we'll look at some examples in the next video.